The neutral bar in an electrical panel serves as the central connection point for the neutral conductors, which are typically white wires, in a circuit. The grounding conductor, identifiable as a green or bare wire, operates independently from the neutral conductor. Its primary function is to provide a low impedance path to earth. In specific electrical setups, isolating the neutral bar from the electrical cabinet is essential. This isolation prevents stray currents from traversing through the cabinet, thereby mitigating electrical hazards and minimizing interference with sensitive electronic equipment. In a standard electrical installation, the grounding conductor is linked to the neutral bar within the meter can. This connection establishes a closed circuit encompassing the grounding conductor, the panel, and the grounded conductor. However, it's crucial to note that this bonding does not automatically connect the neutral bar to the electrical cabinet. The electrical cabinet necessitates grounding and bonding procedures separate from the neutral bar. This typically involves connecting the grounding conductor to the cabinet's metal frame or to a designated grounding electrode. Bonding the cabinet to the grounding system ensures that any stray currents are safely directed to earth. Despite the neutral bar and grounding conductor being bonded in the meter can, several reasons underscore the importance of maintaining the isolation of the neutral bar within the electrical cabinet. Firstly, safety is paramount. Isolating the neutral bar effectively prevents stray currents from flowing through the cabinet, thereby reducing the risk of electrical shock. Secondly, it aids in electromagnetic interference, or EMI, reduction. Stray currents can generate EMI, which can disrupt the functionality of sensitive electronic equipment housed within the cabinet. Thirdly, it ensures code compliance. Electrical codes in many jurisdictions mandate the isolation of the neutral bar from the cabinet to uphold safety standards and ensure proper functionality. In conclusion, while the neutral bar and grounding conductor are technically bonded at the meter can, it's imperative to maintain the isolation of the neutral bar within the electrical cabinet. This practice is vital for ensuring safety, mitigating EMI, and adhering to electrical codes. By keeping the neutral bar separate from the cabinet, stray currents are minimized, potential electrical hazards are reduced, and proper grounding and bonding are assured. Considering a typical residential electrical system, the power enters through the service entrance conductors and terminates at the meter. From the meter, the conductors proceed to the main electrical panel, often located inside the house. The main electrical panel is where the circuit breakers are housed, distributing power to various branch circuits throughout the home. The neutral bar in the main panel is a critical component, serving as the termination point for all the neutral conductors returning from these branch circuits. The grounding system is equally important. It consists of the grounding electrode conductor, which connects the grounding system to a grounding electrode, such as a ground rod or a metallic water pipe. The grounding electrode provides a path for fault current to return to the source, tripping a circuit breaker or fuse and energizing the circuit. Now, let's address the specific concerns about bonding the neutral bar to the ground in the meter can and its implications for isolating the neutral in the main panel. According to the National Electrical Code, or NEC, the neutral conductor is permitted to be connected to the grounding electrode conductor at the service equipment. This connection is typically made in the meter can or the main service disconnect. The purpose of this connection is to provide a low impedance path for fault current to return to the source, ensuring the prompt operation of overcurrent protective devices like circuit breakers or fuses. However, the NEC also stipulates that the neutral conductor must be isolated from the equipment grounding conductors downstream from the service equipment. This means that in the main electrical panel and subsequent subpanels, the neutral bar must be kept separate from the ground bar. The reason for this requirement is to prevent neutral current from flowing on the equipment grounding conductors. If the neutral and ground were bonded together in the main panel, a portion of the neutral current would find its way onto the equipment grounding conductors, creating a potential shock hazard. This is because the equipment grounding conductors are connected to the metal enclosures of electrical equipment, and if they carry neutral current, these enclosures could become energized. The isolation of the neutral bar in the main panel ensures that neutral current is confined to the neutral conductor, while the equipment grounding conductors only carry fault current during a ground fault condition. Now let's address the concern about bonding the meter can and the cabinet to the grounding system. Bonding refers to the practice of connecting all metal parts of the electrical system together to create a low impedance path for fault current. This includes the meter can, the main electrical panel enclosure, and any metallic conduits or enclosures that contain electrical conductors. The purpose of bonding is to ensure that all metal parts are at the same potential, minimizing the risk of electric shock. When a fault occurs, the fault current will flow through the bonding conductors back to the source, tripping a circuit breaker or fuse and energizing the circuit. The NEC specifies the requirements for bonding in Article 250. It mandates that all metal parts of the electrical system be bonded together using approved methods and materials. This includes the use of bonding jumpers, bonding bushings, and other listed devices. The size of the bonding conductors is also specified in the NEC and is based on the size of the circuit conductors. So, while it may seem redundant to bond the neutral to the ground in the meter can and then bond the can to the ground and the cabinet to the ground as well, each of these connections serves a specific purpose. The bonding in the meter can provides a low impedance path for fault current to return to the source. The bonding of the meter can and the cabinet ensures that all metal parts are at the same potential, minimizing the risk of electric shock. And the isolation of the neutral bar in the main panel prevents neutral current from flowing on the equipment grounding conductors, further enhancing safety. Consider an example. Suppose there is a ground fault in a branch circuit. The fault current will flow from the hot conductor to the metal enclosure of the faulty equipment. Because the equipment enclosure is bonded to the grounding system, the fault current will flow back to the source through the grounding conductors and the bonding conductors. This high current will quickly trip the circuit breaker, protecting the circuit, energizing the circuit, and preventing a sustained shock hazard. If the neutral and ground were bonded together in the main panel, a portion of the fault current could flow on the neutral conductor, potentially energizing other metal enclosures connected to the neutral. This could create a dangerous situation, increasing the risk of electric shock. By isolating the neutral bar in the main panel and properly bonding the electrical system, the risk of electric shock is minimized and the safety of the electrical installation is enhanced. One might think of the grounding and bonding system as a safety net that is there to protect people from electrical hazards. It provides a path for fault current to return to the source, tripping the circuit breaker or fuse and energizing the circuit. It also ensures that all metal parts of the electrical system are at the same potential, minimizing the risk of electric shock. Adhering to the NEC requirements for grounding and bonding is essential for ensuring the safety of electrical installations. This includes properly sizing the grounding and bonding conductors, using approved methods and materials, and inspecting the connections to ensure they are tight and secure. The NEC provides detailed requirements for grounding and bonding in Article 250, covering various aspects of the electrical system, including service equipment, branch circuits, and equipment enclosures. Consulting the NEC and seeking guidance from a qualified electrician is crucial for ensuring that the grounding and bonding system is installed correctly and functions as intended. In addition to safety, proper grounding and bonding also help to reduce electromagnetic interference, or EMI, and improve the performance of sensitive electronic equipment. EMI can be generated by electrical equipment and can interfere with the operation of other electronic devices, causing malfunctions or errors. A properly grounded and bonded electrical system can help to minimize EMI by providing a low impedance path for unwanted electrical noise to dissipate. This is particularly important in commercial and industrial environments where sensitive electronic equipment is commonly used. It is also important to note that the grounding and bonding requirements may vary depending on the type of electrical system and the specific application. For example, the grounding and bonding requirements for a separately derived system, such as a generator or an isolation transformer, are different from those for a standard electrical system. The NEC provides specific guidance for grounding and bonding separately derived systems in Article 250. Therefore, it is essential to consult the NEC and seek guidance from a qualified electrician to ensure that the grounding and bonding system is installed correctly and meets the applicable requirements. Moreover, regular inspections and maintenance of the grounding and bonding system are essential for ensuring its continued effectiveness. This includes inspecting the grounding and bonding conductors for damage or corrosion, tightening any loose connections, and testing the grounding electrode to ensure it is providing a low impedance path to earth. The frequency of inspections and maintenance will depend on the environment and the type of electrical system. However, it is generally recommended to inspect the grounding and bonding system at least once a year. In conclusion, understanding the relationship between the neutral bar and the grounding conductor, the importance of isolating the neutral bar in the main panel, and the rationale for bonding the meter can and the cabinet to the grounding system are crucial for ensuring the safety and performance of electrical installations. By adhering to the NEC requirements for grounding and bonding, potential electrical hazards can be minimized, and the safety of people and property can be enhanced. Furthermore, proper grounding and bonding can help to reduce EMI and improve the performance of sensitive electronic equipment. Consulting the NEC and seeking guidance from a qualified electrician are essential for ensuring that the grounding and bonding system is installed correctly and meets the applicable requirements. Regular inspections and maintenance of the grounding and bonding system are also crucial for ensuring its continued effectiveness. Remember that the electrical system is a complex and potentially dangerous system. Working on electrical systems should only be done by qualified and experienced individuals. If you are not comfortable working on electrical systems, it is always best to call a qualified electrician to perform the work. The NEC serves as the cornerstone for safe electrical practices. The NEC Article 250 contains comprehensive requirements for grounding and bonding, ensuring electrical systems operate safely and effectively. Following the NEC guidelines, one can mitigate potential hazards such as electrical shocks and fires, while also protecting sensitive electronic equipment from damage. Moreover, the NEC undergoes regular updates to incorporate technological advancements and address emerging safety concerns. Staying informed about the latest edition of the NEC and its revisions is crucial for electrical professionals and anyone involved in electrical work. The process of isolating the neutral bar and properly bonding electrical equipment might appear complex, but its importance cannot be overstated. By adhering to these practices, one can create a safe and reliable electrical system that protects both people and property. Consulting with qualified electricians and electrical inspectors ensures compliance with the NEC and local electrical codes, guaranteeing the highest standards of safety and performance. The correct implementation of grounding and bonding techniques is not merely a matter of compliance, it is a fundamental aspect of responsible electrical system design and installation. It safeguards against potential hazards, promotes reliable operation, and contributes to the overall well-being of individuals and the longevity of electrical equipment. Therefore, a thorough understanding of these principles is essential for anyone involved in the electrical industry. Also, remember to take into consideration the type of equipment being used. For example, if using a generator as the power source, a different set of rules apply with NEC Article 250.